The purpose of this video is to give a simplified explanation of how lateral forces, which include both wind and seismic forces, are distributed in wood frame structures. Shown here is a multi-story wood frame residence on a concrete foundation. Both wind forces and seismic forces act on a building in a similar fashion. They can impact the building horizontally or perpendicularly to the framing system, or they can impact the building on an angle, creating a racking and torquing forces. Regardless, both types of forces are handled in the same way with the same systems within the structure. The two primary components to handling these forces in this type of structure are the horizontal diaphragms and the vertical diaphragms. The horizontal diaphragms typically consist of the roof framing structure and any floor framing structures within the building. The vertical diaphragms are typically referred to as shear walls and can occur either on the exterior or have interior locations within the structure. Both systems, horizontal and vertical, rely on sheathing to transfer the loads. In this situation, we have OSB sheathing subfloor, 3/4 inch, and on the wall system we have 1/2 inch OSB sheathing on the exterior of the wall. The OSB sheathing in and of itself is not capable of handling the forces. It's actually quite flimsy material. However, by incorporating it into a floor framing system, and we've done a little cutaway here and a cutaway here so that we have a better understanding of how the relationship of the components, we'll call it. This system is of the floor framing system, we'll call it, consists of the subfloor sheathing, floor joist, a rim joist, any blocking required, and of course nailing. The wall framing system, the shear wall, consists of the OSB sheathing, in this case 1/2 inch, the studs, the top plates, the bottom plate, the rim joist, and its nailing system specifications. The nailing occurs in the sheathing in two locations. There's the field nailing, which is typically spaced at 12 inches on center, and there's the edge nailing, which is typically spaced closer, usually 6 inches or less. The necessity of the edge nailing to be closer is because this is where the forces are transferred. The forces move through the floor diaphragm, they get transferred from element to element all the way over to the wall system. And it's at this location where the critical transfer of forces takes place. So all these forces are gathered, brought over to the vertical diaphragm, the shear wall, and transferred down. The failure in any location of the nailing system compromises the integrity of the building and the ability for continuity of transferring the forces down. This nailing system can fail in several ways. Through excessive shrinking from excessive moisture being in the framing members at one time or another, create a situation where the nails have reduced holding capacity. The nails could bend or break in shear through forces. And finally, the ability to transfer the load can be compromised by the deterioration of the OSB sheathing. If any one of these three conditions takes place, the structural integrity of the entire system is compromised. At any given point in the system, if there is a failure, the system fails. So it is necessary and critical to have all components working together and working as engineered.